Okay. Just forget about this. Now, for example, uh, what I have done in the recursive, I have said define fact n, and if I say that if n is greater than equal to 1, then return 1. Else, what I have said, return n multiplied by fact of n minus 1, right? So in this case, this is your base case, because whenever, sorry, less than equal to, right, less than equal to 1, then we are returning 0. So this is our base case. Here we are calling the function, and the third is that it is reducing. It is reducing. So these three conditions must be satisfied for any function to be considered as recursive. Fine. Now the same thing we can do with the help of for loop also. So I will write the syntax for I is equal to 1 to 5, and I will say here f is equal to 1, f is equal to f into I, right? This thing also I can do. So this is called as iterative method. Iterative method. So this is simple and effective also, you can say, because simply the statements are executing for 5 times, that's all. Here every time the first function is calling to next function, next is calling to next function, likewise 5 times it will happen, and then it will come back, come back, come back. Okay, so this is more time consuming. But why I have explained this, because this is a very good example for explanation purpose in recursive, because we can see that every time the stack was created here, the stack was created in the form of ADT, stack was created, right? So every time the function is called, the stack is created, memory is allocated, and every time when it is written, the return address is popped from this ADT, right? Activation record, we call it as ACT, sorry, activation record, which is in the form of stack, right? So it is time consuming, but for explanation purpose, we have considered this example. Otherwise, in real life, we won't implement factorial by recursion. But certainly, there are some cases where we cannot go for with iterative methods. I told you yesterday example of Tower of Hanoi, right? So that is not possible without recursion. Okay, that is not possible without recursion. So here, in such cases, recursion is very powerful. In certain cases, the solution is provided by recursion only, right? So yesterday we have started about trees, and we have
Hello,
seen
sir.
the, yes.
Sir, some students are waiting outside.
Okay. Now I think no one is waiting. All are okay. Admit. See, if all are joining by 11:40 42, then it's fine. So I have to start. I am sharing my screen. Okay. So shall I start again my lecture?
Yes, sir.
Okay, fine. If one by one are coming, then they are automatically admitted. But if all are coming at a time, then I have to click on admit all. Right. So that's the problem in this auto admit feature also. Fine. So where I was, yes. So yesterday we have talked about trees, right? We just forget about whatever is written here and see the blank screen only, right? Suppose I want to store the data, right? I want to store the data in ascending order, right? In ascending order. Fine. Now I will enter data in any random manner. For example, if I enter data 5, 7, 8, 2, 3, 10, right? Now manually, I think anyone can tell me the ascending order of this sequence. It is 2, 3, 5, 7, 8, 10, right? I think all will agree to this.
Yes.
Manually by seeing also we can do this. But the same thing we want to do with the help of data structure, right? Because I want that the moment I insert the data, it should be inserted at proper place, right? Suppose I've inserted 5, then 7, then 8. But moment I insert 2, then it should appear before 5. Moment I insert 3, it should appear before 3. And if I insert 10, then it should appear after 8, right? So this thing should happen at the time of insertion of data, right? So that's where the tree comes into picture, okay? Because you want to arrange something in a order, right? In an ascending order, right? The other thing is that, for example, suppose you are having some strings, say, and the I'm taking simple example is, was, right? He, she, it, for example, right? And I want to search this data. I want to search this data. So what will be the normal solution? That you will store this in a string array, all these string words, and then you will compare it in a sequential manner, right? You will compare it in a sequential manner, and if you found, you will say yes, the string and is found, or the string he is found, or the string it is found in sequential manner. But if you are arranging it in sequential manner, say for example, there are 1 lakhs of words are there, okay, 1 lakhs of words are there, and the word which you want to search is located at the position greater than 90,000. So if you go for sequential search, what will happen in sequential search? You have to search for 90,000 comparisons. You have to do 90,000 comparisons, and which is very time consuming, right? Which is very time consuming. So you want an efficient algorithm for that, right? So the efficient algorithm for searching this kind of is binary search. I think you might have heard this word. I don't know. Binary search. Have you heard this word?
Yes, sir.
Yeah. So what binary search does, actually, I will just tell you that how the binary search works. Suppose the main requirement of binary search is that the number should be in sorted order, right? So I will consider one sorted order here, and that order is suppose say 10, 15, 20, 22, 25, 27, and say 30, right? How many numbers are there? 1, 2, 3, 4, 5, 6, 7 numbers are there. Fine, it's okay. So now I want to search, suppose number 27, right? I want to search this number, whether it exists there or not. If you will go for linear search, what will happen? You will compare this with 27 with 10, no match. You will compare with 15, no match. You compare with 20, no match. You compare with 22, no match. You will compare with 25, no match. You will compare with 27, match. So how many comparisons you have done? 1, 2, 3, 4, 5, 6 comparisons you have done to find out whether 27 is exist or not, right? 6 comparisons. Now the same thing if you will do with the binary tree. What you want to do, binary search, you will divide the income, the sequence into two, half, left half and right half. Okay. So how many numbers are there? 7 numbers are there. You will find the mid. Mid is what? 7 by 2. That is 3.5. So it will be rounded to say 4, right? So it will take the fourth number, 1, 2, 3, 4. It will take this fourth number, for example, and it will compare this fourth number 22 with 27. Now this is sorted order. 22 is not equal to 27. but definitely 27 is greater than 20. That means, since it is a sorted order, what we can conclude that the 27 number, if at all it exists, it will be towards the right hand side of this number, not left hand side. Now there is no question in comparing toward the left hand side, because 22 is smaller than 27, so the number, if at all it exists, it will be toward right hand side, right? So now I won't consider this set of numbers. What you said, I will consider this number 25, 27, and 30. How many numbers are there? 3. So again I will find mid is equal to 3 by 2, that is 1.5 rounded to 2. So which number is there? 27 number is there, right? So now 27 is equal to 27. Yes, match. Then how many comparison we have done? We have done one comparison here, other comparison here. So in two comparisons, we have reached to our target as compared to 6 comparisons. If we go for linear search, right? In binary search, we can compare, find out the number is uh, here or not in two comparisons. So this is the advantage of binary search. So what is happening here? We are calling the same function again and again, but with new limits. With new limits. If suppose I have to search say 14 number, right? Then if I will compare 14 with 22, then 14 is less than 22. So I will go to the left hand side, not to the right hand side. So I will send this as a limit. So this 10, 15, 20, how many numbers are there? 3 numbers are there. 3 by 2, 1.5 rounded to 2. Then 15 you get the number. So 14 is compared with 15, right? 14 is compared with 15. So 14 is less than. So the number doesn't exist here. So single number is remaining there. So I will compare that 14 with 10. No match. So I will say that the number is not found in the list. Number is not found, right? So that also we can check. If we cannot go left or right, then we can conclude the number is not there in the list. Getting? So this is the advantage of binary search. Okay. So I will just show you the program of binary search. Let me check whether it's here. Okay. What I will do? Shall I write the program? What you say? Shall I write the program in front of you? It will take some time then. Yes. Someone can reply.
ओके सर.
Hmm? लिखो क्या मैं?
हाँ सर.
ठीक है. Okay. So what I will do? I will just write that program. Or I can fine. So this I will open the Python editor, right? Then define. I will say binary search. What we require to pass binary search? We require which number to find and what is the array, because we need to pass array also, right? Where those numbers are stored. So we need to pass uh, the number to find. Suppose that is target. What is our target? Then uh, our array. Suppose say my array, right? And then uh, the limits, because initially the entire array will be our limit. Initially you will pass the index of first element and the index of last element. The index of first element is 0. If suppose I will say that, and suppose my array contains the number say 5, 7, 8, 2, 3, 10, for example. So The index of 5 is 0, 1, 2, 3, 4, 5, and the index of 10 is 5. So you will pass 0, comma 5, right? So that will be stored where? In the first and last element, right? So these are the arguments which we will require to pass to the binary search, right? Now, what we need to check is that suppose we are, the numbers are there, suppose for example 2, 3, 5, 7, 8, 10, and we are uh, going either in right direction or in left direction. But always your first should be less than the last, right? You agree on this? The first index must be less than the last index. So since we are going to work this as a recursive function, right? So I have to check whether the index value of first is uh, less than equal to last or not. So if that condition is not satisfied, what I will do, if first is greater than last, right? If first is greater than last, इसका मतलब क्या हो गया कि नंबर नहीं है, right? What we will do, return false. ठीक है? If our index value of first exceeds the last, that means the number is not there in the array, right? Else, now what we need to do, we need to find the mid of the first and last, right? So I will come find out first mid is equal to, in brackets, first plus last divided by 2. So I found mid. Now I want to check whether the mid element of my array is equal to the target or not. So I will say if target is equal to my array of mid, right? My array of mid. अगर है तो हम क्या करेंगे उस केस में, नंबर फाउंड हो गया ना हमको, व्हाट वी विल से, रिटर्न, ओके, target is greater, if target is greater than my array of mid, what we want to do, we need to set the new value of first, right? So then our first will be equal to what, mid plus 1. फर्स्ट क्या हो जाएगा, मिड के बाद में का हो गया, and then what we will do, we will again call binary search function to target my array first, comma last. That I can do, right? Else if suppose target is equal to, then it will true. Else if target is greater than my array, it will call this else. What is the meaning of this else then? ये else का मतलब क्या होगा, टारगेट जो है वो लेस है ना, तो लास्ट इज इक्वल टू मिड माइनस 1. ठीक है, अगर लेफ्ट हैंड साइड में है तो लास्ट क्या हो जाएगा, मिड माइनस 1 हो जाएगा, फर्स्ट वही रहेगा. एंड देन अगेन आई विल कॉल बाइनरी सर्च टारगेट माय अरे, कॉमा फर्स्ट, कॉमा, okay. So I can say here we have to do this thing, right? Return to, and since it is binary, because here see first and last are getting updated, so this is my base case, right? These are my recursive call, and the first and last are getting updated here. Okay, so all the three conditions are satisfied. Fine. Any doubt? So here what I should do, else I should write return. We want to return this.
So,
I want to, yes.
so will we pass index in first and last or the element data?
हाँ क्या क्या
So, will we pass index to as first and last or the data?
No, no, we will pass index only because data is
Okay,
compared here. Na,
sir.
my array of mid. This is the data, right? These are the index value. Because why index value? Because here, suppose your number is there, na? So you want an index value. Suppose this is my first. 0 is first and 0, 1, 2, 3, 4, 5. 5 is last, right? Your first is 0 and last is 5. So f plus l, 0 plus 5 divided by 2, that is 2.5. Okay. So if we truncate or round off, anything it will have either 2 or 3, right? So suppose 2. So 0, 1, 2. What is the number pointed by 2? So it is my array of 2. What is that? 5. And it will be compared with your target, right? If it is matches, it is written true. If it doesn't matches, now what will happen if it's not matching? There are two cases. The target may be greater, the target may be less. So if target is greater than 5, what will happen? These numbers are of no use then. So your first will update from 0 to the next. So first will become mid plus 1, right? And if it is target is less than the mid of element, then these number of no use, and your last will be updated to this value, right? So your in that case your last will be mid minus 1, and you will again do the same thing, right? Again you will do the same thing. Got it?
Yes, sir.
Yeah. So I have written this code. Now I will write the main code. What I can do, I array. Uh, how I can declare? I can write declare like this: 2, 3, 4, 5.
Hello, sir. I have one more
Huh?
doubt.
Yes.
I guess we'll get index error.
Why?
Also, because if we see mid, then it can be a floating number.
No, no. It will be convert to integer, na? It will convert to integer, right? That auto
Not
conversion
for the.
feature will be there, and if error comes, then we will see what we can do, right?
Okay, sir.
हम
So I guess
देखेंगे.
we can use. We should use double slash. The
Okay. So you want to say that you want integer part only, right?
yes, sir. Yeah.
डबल स्लैश, ठीक है ना? तो ये देखो ये कैसा रहता है, पहली बार हमने गलती, तो गलती समझ में आएगी हमको, और गलती समझ में आने के बाद में फिर हम देखेंगे कि हमको करना क्या है, राइट? अभी चूंकि आपने प्रोग्राम कर लिया है इसलिए आपने पहले से बता दिया, ठीक है, कोई दिक्कत नहीं। 20 लिख दूँ मैं यहाँ पर ऐसा, और अब मुझे क्या करना है? इफ binary search, I will call this function. What is my target? Say my target is 7, uh, and I will pass my array. Then my first is 0, and what will be the last? 0, 1, 2, 3, 4, 5, 6. 6, right? If found, what I will say? I will say print number found, right? Else, what I will say? Print number not found. ठीक है? अभी हमने क्या लिया? एरे में 2, 3, 4, 5, 7, 8, 20, और फाइंड आउट करना है हमको 7। 7 है तो हमको फाउंड मैसेज आना चाहिए, राइट? इनवैलिड सिंटैक्स में क्या हो गया? ये एरर बताएगा कोई? एक ब्रैकेट और लगाना था, दो ओपनिंग थे ना, दो क्लोजिंग चाहिए थे। What message we have got? Number found. Okay. Then suppose instead of 7, if I give say 9, right? Then what message should occur? Number not found, right? So in this way, we are doing the searching operation with very less number of comparison as compared to linear search. So this is the power of recursion, right? ये किसका power है? Recursion का power. Because it is going to call itself with reducing limits of first and last. See here, our first is updated and here our last is updated. So every time it will call, it will have some different value of first and different value of last. And that is the exit condition. If your first exceed last, मतलब first अगर आगे चले गया last के, इसका मतलब क्या है? Number है नहीं. So if first exceed last, I will return false. Else I will return true only if the number match. If number doesn't match, then I will again call the function. Right. So any doubt here? In case of binary search recursion, किसी को डाउट है?
No,
हाँ
sir.
ना,
नो
हाँ
सर.
हाँ ना बोलते रहा करो, समझ में नहीं आया तो, क्योंकि आप लोग मुझे देख नहीं रहे हो, राइट? इसलिए आपके एक्सप्रेशन से देख नहीं पाता हूँ, तो मुझे समझ में नहीं आता. आपको समझ में आ रहा है, बोलेंगे तभी समझ में आएगा. ओके, सो नाउ व्हाट इज अवर, क्या बोलेंगे उसको हम लोग, our role now, that how to insert, how to create the tree, right? हमारा सबसे पहला काम क्या होगा कि हमको ट्री को क्रिएट करना है, right? और ट्री को कैसे क्रिएट करना है कि डाटा आपका असेंडिंग ऑर्डर में होना चाहिए, राइट? हमको पता है कि जो भी फर्स्ट नोड है आपका, द फर्स्ट नोड इज कॉल्ड एज रूट नोड, राइट? एंड इन केस ऑफ बाइनरी ट्री, every node will have at the most 2 child, right? So ये इसका लेफ्ट साइड हो गया और ये इसका राइट साइड हो गया. So this is called as left node of root and this is called as right node of the root. L and R are children of root and we can say what is the size of this tree? Size of tree क्या होगा? कोई बता सकता है? कल बताया था मीनिंग मैंने साइज का. What is the meaning of size of tree?
3.
Yeah. How many number of nodes are there in a tree? That is called as size of tree. And what is the level of this? The level is
1.
0 year and the level is 1 year, right? And what is the height? Height is 2,
2.
right? 1, 2. Height is 2. There are 2 levels, 0 and 1, right? So these were the some terms which we should know whenever we are working with tree, fine. So now we want to create a binary. For creating a binary tree, what is required? First, we want to create a root node, right? First, what we will do, we will create a root node, right? With any value, whatever value you want to give, you can give the node that value. Okay. Then the next is what you want to insert a new node, right? Now, what will be the policy for inserting the new node? Can anyone tell me? जैसे जैसे बोला ना, हम एक पॉलिसी लेके चलते हैं कि always the, suppose the root node is having value 10, any node with data less than 10 will be on its left hand side and any data with greater than value 10 will on its right hand side. That policy will adopt throughout our explanation of tree. What is the policy? That left node will always have value less than its parent node, right? लेफ्ट नोड का वैल्यू हमेशा पैरेंट नोड से कम होगा और राइट नोड का वैल्यू हमेशा पैरेंट नोड से ग्रेटर होगा. दिस पॉलिसी विल फॉलो थ्रूआउट आवर एक्सप्लेनेशन ऑफ बाइनरी ट्री. इसमें कोई डाउट? कोई लोग उल्टा भी कर सकते हैं. अगर मान लो कोई अपना फंडा लगाना चाहता है तो ही कैन डू द रिवर्स ऑल्सो. बट मैं क्या करूँगा, मैं यही फंडा फॉलो करूंगा, लेफ्ट नोड शुड बी लेस देन पेरेंट नोड, वैल्यू ऑफ लेफ्ट नोड, and right node should be greater than parent. This will be policy will be adopted correctly. In most of the cases, this policy is only adopted. Right? इसके कारण बताऊंगा मैं आपको कि ऐसा क्यों करते हैं. Right? That I will tell you. So now insert a new node to left if data of new node is less than data of root node. मतलब रूट नोड की जगह हम क्या बोल सकते हैं यहाँ पर, पेरेंट नोड बोल सकते हैं, बट चूंकि एक ही नोड है तो हम रूट नोड बोल सकते हैं. राइट. और insert a new node to right of data if new node is greater than data of parent node. Right. दोबारा नहीं लिखता हूँ. ये पॉलिसी समझ में है आपको? ठीक है. अब अगर हम ऐसा मान के चलते हैं कि इंटरमीडिएट ट्री हमने क्रिएट करके रखी है. ठीक है. कल भी मैंने बताया कि आपको लॉजिक डेवलप करने के लिए क्या करना है, इंटरमीडिएट ट्री एज्यूम करना पड़ेगा. मान लो यहाँ पर 10 है, ये यहाँ पर 5 है, यहाँ पर 15 है और यहाँ पर 3 है. ये ऐसी इंटरमीडिएट ट्री. नाउ यू वांट टू इंसर्ट अ नोड विथ वैल्यू 7. ठीक है. क्या करना है मुझे, 7. अब शुरुआत कहाँ से करूँगा, ऑलवेज आई विल स्टार्ट फ्रॉम रूट नोड. राइट. द वैल्यू ऑफ रूट नोड इज 10 and the node which you want to insert is having value 7. So 7 is less than 10. So you will go to the left node of the root. Now here the left node exists, right? So if left node exists, what you will do, you will compare the value of left node with the insert node. Now the left node is having value 5 and the insert node is having value 7, which is greater than 5. So you will go to the right portion of this. Now the right node of 5 is none, it is not there. So if right node of the 5 is none, you will create a new node, and to the right of this node, which is left of root, है ना, रूट का लेफ्ट है, तो इसके राइट में नया नोड क्रिएट करेंगे एंड वी विल save the value of that node, 7 value of that node here. Okay. And 5 will 5 का जो right होगा will point to this new node. Right. 5 का जो right होगा that will point to new node. Another example we will take. Suppose I want to insert say 12. क्या insert करना है मुझे, 12. So again I will start with root. The value of root is 10. The value which you want to insert is 12. So you will go to the right hand portion of this node. Now the node exists here, so no issue. You will check the value of this node again with the 12. Now the value of 15 is greater than 12. That means 12 is less than 15. So you have to go to the left hand side of this node. Now whether the left node exists, no. So you will create the node and you will put value here and you will store the left part of this node, because every node contains 3 fields: data field, left and right. So to the left you will store the address of this newly created node. So this left will point to 12. Right. Any doubt in this, how the nodes are inserted?
No, sir.
Okay. So what we will do, we will write the code for inserting the nodes. Right. How the nodes are inserted, that we will see. Definitely there will be a recursion in this case, and when the recursion will end, can anyone tell me when the recursion will end? Base case,
If
what
the
will be the
data
base
is
case?
none.
If the left or right node data is none. Means if the node is, if the intermediate node is pointing to a none left or none right, right? That will be my base case. Okay. So let us now write down the program for insert. Okay. or this. So what we will do, we will first write the function define insert, and what we will pass to this, the self address and data, right? Now very first, whenever you are about to create a tree, the value of self, suppose if we are considering an intermediate tree, right? If we are considering an intermediate tree, example I had given like this, because this is 10, this is 5, and this is 3, and you are going to insert 7, right? So I will pass first 7 to here, right? What I will do, I will call the function insert and I will pass 7. Okay, so this 7 will come here. Now I have to check whether the data is less than self dot data. Right? This self dot data means what? The root node. Huh? We have to pass the value of root node here. So self dot data and data. This data is 7 and the self data is 10. So 7 is less than 10. Yes. So that means we go to the left hand side. Now here you have to check whether the node exists on the left hand side or not. If the node is not existing, suppose only the scenario is like this, then only one node is there, that's all. So whether the left node exists here? No. So what will happen? We will create a node and put the 7 in that, and the left of this node will contain this address. So we have to check whether the node, that means self dot left, is none or not. I will check here if self dot left है ना, लेफ्ट पोर्शन इज नन। अगर सेल्फ डॉट लेफ्ट नन है, इसका मतलब क्या है, यहाँ पे कोई नहीं है, तो आपको जो सेल्फ डॉट लेफ्ट में क्या स्टोर करना पड़ेगा अपने को, नया नोड। सो सेल्फ डॉट लेफ्ट इज इक्वल टू नोड, we will create a node and we will pass the value data. So self dot let is equal to node and data. अगर नन नहीं है, मतलब यहाँ पर कुछ डाटा है, मान लो 5 है फॉर एग्जाम्पल, इट इज नॉट नन, तो एल्स क्या करेंगे, फिर हम दोबारा इसी फंक्शन को कॉल करेंगे इंसर्ट को, फिर आगे चेक करो। तो एल्स व्हाट वी विल डू, इंसर्ट करेंगे, सेल्फ डॉट लेफ्ट में इंसर्ट करेंगे, सेल्फ डॉट लेफ्ट डॉट इंसर्ट एंड आई विल पास डेटा टू। मान लो लेफ्ट में ऑलरेडी नोड है, तो फिर हम क्या करेंगे, दोबारा इसको रूट नोड मान के चलेंगे और दोबारा इंसर्ट फंक्शन कॉल करेंगे। सो दिस इज कॉल्ड एज रिकर्शन। लेफ्ट में अगर कुछ नहीं है तो लेफ्ट में नोड बनाओ, लेफ्ट में अगर नोड है सो अगेन you call the insert function with this node as a root node. Initially this was a root node, but since this root node contains a left node, now again we have to insert the 7. So again we will call the insert function with this as a root node and 7 as a data, right? And else if data is greater than self dot data, मतलब क्या हो गया, राइट हैंड साइड में जाएंगे हम लोग, तो राइट हैंड साइड का चेक कर लेने का, इफ सेल्फ डॉट राइट इज नन, जैसा लेफ्ट में किया वैसे राइट में करना है। सो सेल्फ डॉट राइट इज इक्वल टू नोड एंड डेटा, और अगर वहां पर नोड है तो फिर से क्या करेंगे हम लोग, एल्स सेल्फ डॉट राइट डॉट इंसर्ट एंड आई विल से डेटा। ठीक है, लेस रहा तो इधर, ग्रेटर रहा तो लेस रहा तो इस तरफ, ग्रेटर रहा तो इस तरफ। अब एक गलती हम क्या कर सकते हैं, मान लो आपका रूट नोड पे वैल्यू 10 है और आपने वापस 10 पास कर दिया, राइट? तो अब 10 तो ना लेफ्ट में आएगा ना राइट में आएगा, राइट? सो ये कंडीशन भी सेटिस्फाइड नहीं होगी, ये कंडीशन भी सेटिस्फाइड नहीं होगी। इसका मतलब क्या है कि नया नोड बनाना है क्या हमको, whether we need to create new node, नो, सो इन दैट केस वी वोंट डू एनीथिंग। फिर हम क्या करेंगे, कुछ नहीं करेंगे। या कहीं कहीं कभी कैसे लिखते हैं, फिर अगर लिखना ही है आपको, कोड कंप्लीट
सर
करना है। हाँ।
सर आपने यहाँ पे लिखा है इफ डेटा इज लेस देन सेल्फ डॉट डेटा,
हम्म।
और उसके बाद एल्स इफ लिखा है, वो एल्स होगा ना?
नहीं, एलसिफ भी कर सकते हैं, एलसिफ भी कर सकते हैं, यहाँ पे कोई प्रॉब्लम नहीं, क्योंकि आगे और मेरा एल्स आ सकता है ना। अगर यहीं पे खत्म हो गया तो एल्स चलेगा, राइट। बट मैं आगे और लिखने वाला हूँ, इसलिए मैंने एलसिफ लिखा एक्चुअली, क्योंकि मैं आगे क्या लिखने वाला हूँ यहाँ पर, एल्स लिखने वाला हूँ। तो अगर लेस है तो ये, ग्रेटर है तो ये, इक्वल है तो क्या, राइट। ये तो लेस हुआ तो ये हो गया ना, ग्रेटर हुआ तो ये हो गया, तो तीसरी कंडीशन कौन सी बची,
हाँ राइट
इक्वल की।
सर।
तो इसलिए इफ लेस देन तो ये पोर्शन होगा, एल्स इफ ग्रेटर देन तो ये पोर्शन होगा, एल्स इक्वल है तो क्या होगा। तो इक्वल है तो हमने क्या किया, सेल्फ डॉट डेटा इज इक्वल टू डेटा, कोई नोड नया बनाना नहीं हमको। तो ये पोर्शन भी लिख सकते हैं, या फिर इसको हम इग्नोर भी कर सकते हैं, देयर इज नो यूज। बट अगर यहाँ पे एल्स इफ लिखा है तो ये करना पड़ेगा। अगर एल्स इफ नहीं लिखा आपने, केवल एल्स लिखा है यहाँ पर, तो कंपेयर करने की भी जरूरत नहीं फिर, और ये पोर्शन की भी जरूरत नहीं रहेगी आपको इन दैट केस, राइट। ये करने की जरूरत नहीं, ये एल्स और सीधा इधर आ जाएंगे, दैट्स ऑल। ये भी कर सकते हैं, लेकिन जस्ट एक रीडेबल बनाने के लिए कि भाई लेस है तो क्या करना है, ग्रेटर है तो क्या करना है, इक्वल है तो क्या करना है, अगर ऐसा लिखना है तो ये लिख सकते हैं आप। ये थोड़ा रीडेबल हो जाता है प्रोग्राम। सी व्हाट हैपेंस, द प्रोग्राम मस्ट बी रीडेबल आल्सो, it should work also, at the same time it should become readable also। मान लो ये पढ़ने के बाद क्या होगा फिर, तो मैंने केवल एल्स ले लिया, तो लेस देन है तो इट्स ओके। अब ग्रेटर देन इक्वल टू होगा मान लो, है ना, इसमें क्या आ जाएगा, ग्रेटर देन इक्वल टू अगर हो गया तब भी वो नोड बना देगा, है ना। तो वो होना चाहिए क्या, नहीं, इसलिए अपने को ये कंडीशन डालनी पड़ेगी। वी कैन नॉट अवॉइड दिस कंडीशन, ग्रेटर है तो ही नोड बनाना है, इक्वल है तो नोड बनाना है क्या हमको, नया नहीं। तो एल्स, फिर हम डाटा ग्रेटर देन सेल्फ डॉट डेटा है तो हम ये करेंगे। तो एल्स लिखने के बाद में फिर हम क्या करना पड़ेगा, हमको यहाँ पे एल्स इफ लिखना पड़ेगा ना, क्योंकि एल्स के बाद में दोबारा हम कंडीशन चेक कर रहे हैं, इसलिए यहाँ पर एल्स इफ आएगा। और ये एल्स इफ का सिंटैक्स पूरा करने के लिए हमको क्या लिखना पड़ेगा, एल्स लिखना पड़ेगा, तब ये प्रोग्राम रीडेबल हो जाएगा, अदरवाइज सिंटैक्स में थोड़ा प्रॉब्लम आ सकता है। सो एल्स सेल्फ डॉट डेटा इज इक्वल टू डेटा, मतलब क्या कर रहे हैं हम लोग, नया नोड नहीं क्रिएट कर रहे हैं। आपने 10 ऑलरेडी नोड नोड आपके पास 10 है, आपने दोबारा 10 बोला तो उसने क्या किया, केवल ये 10 वैल्यू यहीं पे वापस डाल दी उसने, दैट्स ऑल, और कुछ नहीं किया। मतलब द सेल्फ नोड हैज बीन रिप्लेस इट्स ओन वैल्यू, उसकी वैल्यू वापस रिप्लेस हो गई, इतना ही इसके अंदर होगा। गेटिंग, एनी डाउट, हेलो,
It's clear, sir.
shall I explain again or doubt is cleared? See, one thing
Clear sir.
what you have to look after, that whenever you want to insert the node, you have to check its left and right. When you will check left, if the value is less, you will check the left. If the value is greater, you will check right. If the value is less than, then you check whether the left node exists or not. If the left node is not existing, you will create a new node and assign that node as a left of its parent, है ना, assign that node as a left of its parent. But if node exists, then what we will do, we will repeat the same thing again compare the value, and if the value is less, then you will go to the left portion, if the value is greater, you will go to the right portion, and this thing will go on continuously till you found left as a none or right as a none, depending whether it is less or greater। जब भी लेफ्ट या राइट नन मिल जाएगा आपको, तो आपको नया नोड उसके अंदर डाल देना है, दैट्स ऑल। So what we will do, we will just see that program and we will run that program in section. So I have written the same program here. Uh, Definitely you will require a class node. Now here something will be different as compared to previous programs, right? यहाँ पर हम क्या करेंगे, जो फंक्शन लिखेंगे ठीक है, मैं बताता हूँ उसको, पहले हम देख लेते हैं। दिस इज द कोड विच इज रिस्पॉन्सिबल फॉर क्रिएटिंग अ न्यू नोड। जब भी नया नोड क्रिएट करेंगे तो डाटा जो रहेगा वो सेल्फ डॉट डेटा में जाएगा और उसका लेफ्ट और राइट नन रहेगा। नया नोड का लेफ्ट और राइट क्या रहेगा? हमेशा नन रहेगा। नाउ इफ यू वांट टू इंसर्ट, so again you will call the function insert and will pass the data as a parameter. So I am checking here if data is less than self dot data and if self dot left is none. So in that case what I will do, I will assign the new node to the left portion. Else again I will call the left dot insert function and I will pass the data to that. Right? So this code is responsible for left hand side. But if the data to be inserted is greater than the self dot data, then we will go to the right hand side and we will pass the data to the left hand side. So this is the code which is responsible for creating the new node and storing the data in that. Root object. So root dot insert 50, root dot insert 70, root dot insert 70 डबल कर दिया है मैंने। फिर भी एक ही बार होगा इंसर्ट, 70 दो बार नहीं होगा, एक ही बार होगा। फिर 63, 61, 64, 63, 8, 20। तो यहाँ पे देखो 20 भी दो बार हो रहा है, 70 भी दो बार हो रहा है, राइट। तो ये 20 और 70 विल बी इंसर्टेड ओनली वंस, इट वोंट बी इंसर्टेड डबल, राइट। तो इसको अगर रन करेंगे तो ये असेंडिंग ऑर्डर में दिखेगा आपको। मैं रन करके बताता हूँ आपको। 8, 20, 50, 61, 63, 64, 65 एंड 70। फाइन। तो इस तरीके से आप नया भी वैल्यू डाल सकते हैं, इंसर्ट अगर करना है आपको कुछ। तो आप जो बोलेंगे वैल्यू डाल सकते हैं। हम लोग मान लो 20 की जगह मैंने 50 डाल दिया। 50 के बाद में एक वैल्यू 45 डाल दी लेस, एक 50 से ज़्यादा डाल दिया 70, एक 45 से कम देता हूँ 23, एक 70 से कम देता, एक 45 से ज़्यादा देता हूँ और 50 से कम देता हूँ 48, 48, 48। Now I am giving less than 70, that is 65, greater than 70, that is 75, then less than 65, 63, greater than 75, 78, के बाद में greater than 78, 80 and less than 78, 77। Suppose ऐसे कर रहा हूँ, I am running, you can see 45, 48, 50, 63, 65, 70, 75, 77, 78 and 80। So as long as you are using the tree for creating the node and storing the data in that, if you follow this sequence, right, the nodes are can be treated in ascending order, right। अब ये नोड्स कैसे असेंडिंग ऑर्डर में ट्रीट होगा, एंड फॉर दिस पर्पस द सर्चिंग बिकम्स वेरी इजी। इट जस्ट लाइक बाइनरी, जैसा बाइनरी ना, अगर लेस होगा तो लेफ्ट पोर्शन में आ जाएगा, राइट होगा तो राइट पोर्शन। जो हमने बाइनरी सर्च का एल्गोरिथम इंप्लीमेंट किया, तो विद द हेल्प ऑफ ट्री बाय डिफॉल्ट दिस इज बाइनरी सर्च। ये जो पोर्शन हो गया, ये पोर्शन को ही बाइनरी सर्च का पोर्शन बोल सकते हैं हम लोग। तो with the help of this function we are able to create the tree। डिस्प्ले कैसे किया ये हम बाद में देखेंगे, राइट। कितना समझ में आ गया आपको? हाँ, अगर इतना समझ में आ गया होगा, मैं अगला कोड लेता हूँ। एनी प्रॉब्लम इन दिस?
No problem, sir.
इतने लोग हैं लेकिन मेरे को आवाज केवल 2 ही लोगों की आती है, वन बॉय एंड वन गर्ल, दैट्स ऑल. व्हाट अबाउट अदर्स? आर दे पैसिव लिसनर? यस, रोल नंबर B22, यादव आशीष. आपको समझ में आया? यादव आशीष, रोल नंबर
Yes, sir.
22.
Yes, sir.
यस सर. इसमें बेस केस क्या हो गया? अभी इंसर्ट नोड जो मैंने रिकर्सिव किया, इसमें बेस केस क्या है, आप बता सकते हैं? रोल नंबर 22, यादव आशीष. व्हाट इज द बेस केस इन इंसर्ट फंक्शन? क्योंकि रिकर्सिव हो रहा है ना इंसर्ट, है ना? रिकर्सिव हो रहा है. यहाँ पर बेस केस कौन सा है, बता पाएंगे? यस, रोल नंबर 16, बी डिवीजन 16, शेख फहद. शेख फहद, रोल नंबर 16, बी डिवीजन. Shall I mark you as absent if you are not responding? That means you are not listening to lecture. Sheikh Fahad,
Yes, sir, I am here.
you
I
are
was
here.
connecting my headphones.
हाँ हाँ, इतना लेट तो रिस्पॉन्ड कर रहे हैं, आवाज आ रही है
सर
ना?
मैंने हेडफोन्स नहीं लगाया था, अगर से नहीं लगा था तो एको होती थी आवाज़ सर, इसलिए मैं हेडफोन्स
तो
लगा
आवाज तो आ रहा होगा ना, हेडफोन नहीं लगाया तो मेरा.
हाँ सर, आवाज़ तो आ रहा था, हेडफोन लगा रहा था, वही तो बोल रहा हूँ सर, एको होता
अच्छा,
था, मैं आवाज़ नहीं समझ में नहीं आती।
बताइए बेस केस क्या है इस केस में? ये जो इंसर्ट नोड है, ये जो अपना रिकर्सिव फंक्शन है, इसमें बेस केस कौन सा है, बता सकते हैं आप? ठीक है, मैं क्या करता हूँ, अभी आज यहीं पे स्टॉप करता हूँ. आप सब लोगों को एक एक्सरसाइज करनी होगी जिसमें आप सभी रिकर्शन का एग्जाम्पल फाइंड आउट करेंगे और वो 3 कंडीशन बताएंगे, जिसमें आपको बेस केस बताना है, आपको रिकर्सिव कॉल कहाँ होगा वो बताना है, और आपको रिड्यूसिंग नंबर कहाँ पर हो रहा है, जहाँ पे रिडक्शन आ रहा है, यानी मतलब वो टर्मिनेशन की तरफ जा रहा है रिकर्शन, ये आपको प्रूव करना है. सो 3 केसेस, 3 कंडीशंस यू हैव टू सेटिस्फाई फॉर अ रिकर्शन एग्जाम्पल. वो कल आप लोग मुझे बताओगे, ठीक है?
Sir, can you repeat?
You have to come up with one example in which you will satisfy all the 3 conditions of recursion. One is the base case, second one is the recursive call, and the third one is the reducing case. That means you want to call the function in such a way so that it will go towards the termination point, go towards the base case, right? These are the 3 conditions for any recursive example.